problem. We are trying to find the tension in each string. We have some forces that are angles here. So I've got one tension that goes up to the right, another one that goes up to the left, and I've got force of gravity goes straight down. My angles are 50 degrees on both sides. The fact that the angles are the same on both sides will tell me that the tension on the left side and the tension on the right side will be equal to each other. And that's pretty handy. So step one is drawing all of our forces, which we've done. Step two, we would decide on our positives and our negatives. I would say that up is positive, down negative, right's positive, and left is negative. Now we're going to take a look at the two forces that are angles. We always have to break those into components. Any force that's at an angle gets broken into components. So for the force of tension on the right and the left, they're each going to have an x component and a y component. The x component for this tension is going to go to the right. So I'll call it tension in the x direction. And over here, since the tensions are equal, their components are equal too. So I'll call that tension in the x as well. And now all the forces going up, for those of the components going up, are going to be the same as well. So that would be tension in the y and tension in the y. Now what we're going to do is we're going to figure out mathematically what those are. Now we won't get numbers because we don't know what the tensions themselves are. But we're going to get an equation set up based off of this right triangle right here with tension, Tx and Ty, and the same triangle over there. So they'll be exactly the same. So tension in the x direction, that is the adjacent side of this particular triangle. So that's going to be cosine of 50 degrees multiplied by the tension itself, T. And tension in the y direction, that's the opposite side of the 50-degree angle, so that's going to be the sine of 50 degrees times the tension itself, T. So now we have those. We don't know what the numbers are, but that's okay. We'll be able to solve anyway. So we're going to take a look at the up and down. We're going to add up our up stuff and our down stuff, because if we look at left and right, we'll just get the Tx equals Tx, and that doesn't really get us anywhere. So looking at the up and down, what forces go up? Tension in the y goes up. But I don't just have one of them. I've got one on the left, and I've got one on the right. So I have to make sure I count both tension in the y and tension in the y. And the force of gravity goes down, so that is minus. And all those add up to be 0. We're going to simplify this a little bit. Ty plus Ty is just 2 tensions in the y direction. And that's going to equal our force of gravity pulling down. And this is why we did this step up here with the Tx and the Ty. And so I can do this. I know that tension in the y direction, I don't want T in the y, I want the actual tension. And I know that it equals the sine of 50 degrees multiplied by the tension. And all that stuff still equals the force of gravity. Now I can actually solve for my tension. I just have to divide this 2 sine of 50 degrees. So tension is going to equal the force of gravity all over 2 times the sine of 50 degrees. And we can plug in what force of gravity is very easily. Force of gravity is the mass, which is 15 kilograms times 9.8 meters per second squared, all divided by 2 times the sine of 50 degrees. And when I plug all that into my calculator, what I should get is that my tension in each string is 95.95